Hello my dear young friends and beloved students, myself Srinivas, welcome back to C Level Physics. Today I would like to explain a numerical regarding simultaneous projection of two objects as shown. See here, this is what one tower of height h. Now one body is dropped from its top, another body is projected vertically upwards from its bottom. Both such that both are moving along parallel lines, right? Now you may get some doubts here. What are the doubts here in the situation? See, first question, suppression after t0 seconds. See, one is dropped, another one is projected. Both are moving on parallel lines. Now after some time t0, what is the suppression between those two objects? Now second doubt, a time to meet by both objects. See here, one is dropped, another one is projected. After some time, they might meet or cross over each other. Now, after what time they meet? In fact, that is one more doubt or question arises. Now, third one, height from the ground at which they meet. Right? Suppose if they meet at after some time, what is the actual height from the ground? That is the question. Now, question number 4 or doubt number 4, time after which speeds are equal. Of course, here during their motion after some time, okay, their speeds may be equal. Now what is the time after which their speeds are equal? That is the question. Now in that situation, when their speeds are equal, what is the ratio of distances covered by freely falling object and vertically projected object? That is the question number 5. So these are the points which we are going to discuss now. Now see, first one, suppression after t0 seconds. Okay, now same only writing somewhere here. See this what? Height h of tower. Now, for freely dropped object, what is the distance covered in t0? Let it be x0, right? In case of vertically projected body, in the same time t0, what is the distance covered here? Let it be y0, right? Now what is the combined distance covered by both objects here? x0 plus y0. That is the x0 plus y0 is the combined distance covered by both objects. Now the question is the separation between these two. So what is the separation between these two? This is the separation between two objects. This is what separation. How to get this separation means, now h minus of x0 plus y. H minus of total combined distance covered by both objects, that is h minus of x0 plus y0, right? Now how to find x0 plus y0? Very simple manner here. Now take the equation s equal ut plus of h square with its relative form. Very easy to find x0 plus y0 at a time. See here, you know that s equal to ut plus of 8 square of 8 square, s equal to ut plus of 8 square. In its relative form, s becomes s relative, u become u relative, a becomes a relative, right? S becomes s relative, u becomes u relative, a becomes a relative, but time is absolute. You are not supposed to write t relative. Okay. Now this is what usual formula only, s equal to ut plus of 8 square. Now what is s relative means? What is s relative? The combined distance covered, that is x0 plus y0. Combined distance covered by both objects, x0 plus y0. We are finding at a time, right? That is x0 plus y0, right? x0 plus y0 equal to u relative. What is u relative here? In case of body projected vertical upwards, what is the speed here? Initial speed, that is u. Here u equal to 0. In case of dropped object. Now what is u relative? U minus 0. See, for projected object, initial velocity u. For dropped object, 0. Now relative velocity means u minus 0. That is u minus 0 into t. T means t0 here. Plus half into, what is a relative? A relative means both are subjected to acceleration due to gravity only. Means both are subjected to gravity. Means what is the acceleration of both objects? G downwards. Now relative acceleration means g minus g, that is 0. That is 0 into T naught square. T naught square. Why? Because for first object G downwards, for second object G downwards. Therefore, A relative equal to G minus G. G minus G means 0. G minus G, that is 0. So we left with x naught plus y naught equal to ut naught. Ut naught. This is what combined distance covered by both objects, by dropped object as well as projected object. So what is the combined distance covered? X naught plus y naught, that is equal to u naught, ut naught. Now see, this is what height h, height of the tower. Now what is the separation? This is separation. See, this is what separation between both objects after time t naught. See, this is what position, given position. Alright. Now how to get this separation means h minus of x naught plus y naught. So separation equal to h minus of x naught plus y naught means ut naught. Ut naught, directly ut naught. Ut naught. This is what separation, right? H minus of x naught plus y naught. X naught plus y naught means ut naught. Directly we can write h minus of ut naught. That is what separation between both objects after time t naught. Now question number 2. Time to meet. After what time they meet together? After what time? See, I am writing here. This is what? Tower of height h. Now distance covered by dropped object, let it be x. Distance covered by projected object, let it be y. So as both objects meet together, the combined distance covered must be equal to h, right? That is x plus y becomes equal to h as both meet together, right? Now time to meet means take s equal to ut plus half h square. Again, s equal to ut plus half h square in relative form. S equal to ut plus half h square. That is s relative equal to u relative a relative, right? S relative equal to u relative into t plus half a relative into t square in its relative form, right? Now what is the s relative here? That is x plus y. Combined distance covered by both objects, that is x plus y, which is equal to h. So initially I am writing x plus y. X plus y equal to u relative means u minus 0. Here it is u0 for a dropped object, for projected object u. So u minus 0 into t plus half into what is a relative 0 into t square. Why a relative 0 means acceleration is g for both objects, for a dropped object as well as projected object. That is the relative acceleration is g minus g, that is 0. So we left with x plus y means what? H equal to u into t. H equal to x plus y means h, that is equal to u into t, right? Now that is t equal to h by u. This is what? The time after which both objects meet together, right? Now third question is height from the ground at which they meet. After what height? Means after t seconds, after t equal h by u seconds, both meet together. Now at what height from the ground they both meet means this is what y. Y is the height from the ground. See, this is what ground. From the ground at the height of y both meet together. So what is y? See, this is what height h. This is what distance covered by dropped object x. This is what distance covered by projected object from the ground. This is what ground. Now see, here both are meeting or both are crossing each other at the height of y from the ground. Wow, now what is y here? What is y? Y means what? Y equal to h minus of x. So in case of dropped object, x equal to half gt square, right? X equal to half gt square directly. Why? Because u0 S equal to ut plus half h square, u0, that is a equal to minus g. Otherwise solve here. Otherwise solve. Say in case of dropped object, u equal to 0, right? S equal to minus x, right? A equal to minus g, a equal to minus g. Now take s equal to ut plus half a square. S means what? Minus x. Why? Because this is the level from which body is dropped. Therefore, distance covered by or displacement covered by dropped object equal to minus x. Minus x equal to u0 into t plus half, and a means minus g into t square. That is plus or minus minus cancel, we left with x equal to half g t square. X equal to half g t square. This is what distance covered by dropped object, right? When both meet together. Now what is the height from the ground at which both meet? Means y equal to h minus x. So y equal to h minus x. That is h minus x means half gt square. Half gt square. This is the height from the ground at which both meet. Right? Now question number 4. Time after which speeds are equal. Their speeds are equal. After what time their speeds are equal? That is the question. See, time after which their speeds are equal means in case of dropped object, say this is what initial velocity 0. Now speed, take the equation v equal to u plus 8. V equal to u plus 8. Now after t seconds, otherwise after t dash seconds, its speed is v. Now v equal to u means 0 plus a means minus g. Why? Because gravity downwards. T means let it be t dash, for example. Now t dash equal to mod v equal to see plus or minus gt dash. Why it is negative sign means body is moving downwards. Downwards in the sense velocity is negative. I am taking modulus. Mod v equal to gt dash. G t dash. This is what speed of dropped object after t dash seconds. For projected object, within the same time t dash, what is the speed? Let us discuss. Now see, let us find. This is what projected object with velocity u, right? A equal to minus g here. For this body, take v equal to u plus 8. Again, v equal to u plus 8. That is velocity somewhere here. Let be v, right? Now v equal to u becomes u only. A means minus g into t dash. Here, what is t dash? That is the time after which their speeds are equal. For example, so v equal to u minus gt dash. Here v equal to gt dash. So both speeds are equals. Therefore, gt dash becomes equal to u minus gt dash. So therefore, gt dash equal to u minus gt dash. So 2gt dash equal to u. T dash equal to u by 2g. This is the shortcut relation, right? So 2g dash. See here, gt dash equal to u minus gt dash. So take this gt dash onto LHS. That is a 2gt dash equal to u. T dash equal to u by 2g. U by 2g. This is what the time after which both are having or both acquiring same speed, right? As u means the velocity projection of vertically projected object, right? Now coming to the fifth question. When the speeds are equal after this time, now the ratio of distance covered by dropped object as well as projected object. Where x means distance covered by dropped object, here y means distance covered by projected object when their speeds are equal, right? Now see, this is the dropped object. Okay, This is what dropped object. So this is what total height of the tower. Here distance covered by dropped object, let it be x. Here distance covered by projected object, let it be y. Let it be y. In this question, especially in this question, right? These two are not same. Of course, symbols are same, but theme is different here. Where x means distance covered by dropped object, y means distance covered by projected object. By that time when their speeds become equal, right? Now what is x here? X by y. We need to find x by y. X by y. X means what? X equal to object square. See here, x equal to object square. And taking like this, x becomes object square. Directly you can write of g t square divided by what is y? Y equal to ut minus object square. That is y becomes s equal to ut plus object square. S means y. That is y equal to ut minus object square. U t minus of g t square. In fact, here t means what? T dash. Why? Because you need to find the ratio of x by y, x to y when speeds are equal. After what time speeds are equal? Here t dash. So take t dash here. T dash here also t dash. Right? Now t dash equal to u by 2g. That is of g. T dash means u by 2g. U by 2g whole square divided by u. T means t dash here. T dash means u by 2g. Again u by 2g minus of g t dash square. T dash means again u by 2g. U by 2. That is u by 2g whole square. See, u t dash u by 2g minus of g into t dash square u by 2g whole square. So on simplification we get x by y equal to 1:3. 1:3. Right? See here, we left with u square by 8g. Here u square by 2g minus u square by 8g. So on simplification you will get 1/3. That is 1:3. Means when one body is dropped from its top and another one is projected from its bottom, by that time when their speeds are equal, the ratio of distance covered by dropped object and projected object, that is x by y, equal 1:3. That is 1/3. Now coming to one numerical here. Suppose I am taking numerals here. H becomes, suppose h equal to 100 meter. Height of the tower is 100 meter. Now velocity projection of projected object, let it be 50 meter per second. 50 meter per second. Here it is dropped means u0. See here, one body is projected vertical upwards with a velocity of 50 meter per second from the bottom of tower of height 100 meter. At the same time, means simultaneously one more body is dropped from its top. Now let us see all these points. Now what is the separation after t0 equal to 1 second? What is the separation between these two after t0 equal to 1 second? After 1 second, what is the gap between these two? Suppose x0 is the distance covered by dropped object, y0 is the distance covered by projected object after 1 second. So if you do like this, separation becomes h minus ut0. H means what? 100. I am writing somewhere here directly 100 minus ut0. U means what? 50. 50 into t0. T0 means what? 1 second. That is 100 minus 50 equal to 50 meter. 50 meter. This is the separation between these two. This is what? Separation between both objects, 50 meter. So what is the total height? 100. Right? Gap between them 50. So that means to say that the combined distance covered by both objects is 50 meters. Why? Because 50 plus 50, that is 100. So this is what distance covered by, this is what separation between both objects after 1 second, 50 meters. Right? Now coming to second question. After what time they meet together? See, T equal H by U. If you proceed like that, you will get one shortcut expression, that is T equal H by U. Height of the tower divided by velocity and projection of the projected object. Now T equal H by U. H means what? 100 meter. By U means what? 50 meter per second. 50. That is 2 seconds. So after 2 seconds, both cross each other on parallel lines. On parallel lines like that. So after 2 seconds, both cross each other. Now coming to third one. After what height from the ground, both meet. After what height means what is the height? Y is the height at which both are going to meet. So what is Y means? Y equal to total height of the tower minus distance covered by dropped object. Y equal H minus X. That is H minus object square. What is object square here? Half into G means half into G means 10. T square means T means what? 2 seconds. That is what? Half into G means 10 into T square means T square, 2 square, that is 4. That is 4. 40 by 2, that is 20. So Y becomes H minus X. That is H means 100 minus half into G means 10, for example, into T square. T square means 2 square. 2 square. 40 by 2, 20. 100 minus 20 means 80 meter. 80 meter. So this is the height at which both will meet from the ground. 80 meter, right? 80 meter. Now coming to fourth question. Time after which speeds equal. What is the time here? T dash equal to U by 2G. So if you proceed like that, you will get one shortcut expression like this. T dash equal to U by 2G. What is U? 50 meter per second for projected object by 2G. That is U means 50 meter per second by 2 into G means 10. So 0 0 cancel. 5 by 2 means 2.5 seconds. 2.5 seconds. So after 2.5 seconds, the speeds become equal. Now coming to heights means ratio of distances covered by dropped and projected object when the speeds become equal. What is the ratio here? X by Y equal 1:3. 1:3 means, in fact, if we want to find actual value of X, X becomes X equal to X takes one part out of 4 parts. 1 by 4 of what are the total parts here? 1 plus 3, that is 4 parts. Am I right? 1 plus 3, 4 parts. So X takes one part out of 4 parts. 1 by 4 of total distance. Total height. What is total height? 100 meter. So 1 by 4 of 100 into 100. That is X equal to 25 meter. Right? So if X equal to 25, Y becomes 75. Why? Because total height is 100. X is 25. Y becomes 100 minus 25. That is Y takes 3 parts out of 4. 3 by 4 of total height of the tower. That is 75 meter. 75 meter. So dropped object covers a distance of 25 meters. At the same time, projected object covers a distance of 75 meters when the speeds become equal. So that's how one can find numerical also based on these points. So separation between the objects after some time taken by both objects to meet each other, and the height from the ground at which they meet, and time after which their speeds become equal. At the same time, when speeds become equal, what is the ratio of distances covered. So that's how we can find all these points. Okay, now let's discuss one previous mains question. That is velocity versus time graph in case of body projected vertically upwards. Right? Velocity versus time graph. 2017 main question. So this question appeared 2017 mains. That is velocity versus time graph. Velocity versus time graph for a body projected vertically upwards. Velocity versus time graph in case of body projected vertically upwards. See, body projected vertically upwards from the ground like that. So initially it retards during ascending motion. Again during descending motion it accelerates. So same only represented in next line like that. See, this is what ascending motion, this is what descending motion. Right? So during ascending motion it is under retardation. During descending motion it is under acceleration. Right? Now velocity time graph. In case of ascending motion, see like that. Okay, so it is projected some initial velocity like that. A becomes minus g. Why? Because g always acting downwards. At highest point velocity becomes 0. Why? Because it is under retardation. So speed gradually decreases and becomes 0 at highest point. Right? Now take v equal to u plus a. V equal to u plus a. So v equal to u positive. Why? Because this is our reference line. Ground is our reference line. Body moving along positive axis from the reference line. Therefore u positive. G downwards. That's why minus g into t. That is v equal to minus gt plus u. V equal to minus gt plus u. We need to estimate velocity time graph. So velocity on y-axis, time is on x-axis from given data, given options. So y equal to, it is in the form of y equal to minus mx plus c. Y equal to minus mx plus c. What is the form here? This is the form. Y equal to minus mx plus c. This is what velocity at time y equal to minus mx plus c. Right? This is the required form. Now during descending motion like that. Descending motion. So this first part is over. Now coming to the second part like that. Downward arrow. So during descending motion velocity, initial velocity 0. A equal to again minus g. Right? It is v. Okay, same formula again. V equal to u plus a. V equal to u plus a. V equal to u means what? Especially for downward motion of projected object, the initial velocity 0, that is 0. A means minus g into t. That is v equal to minus gt. V equal to minus g. Here velocity comes with negative sign. Why it is negative sign means, see, during ascending motion the velocity is upwards, means along positive axis. But after reaching highest point, it retraces downwards like that. Means, see, at highest point, direction of motion is reversal beyond highest point. After reaching highest point, particle retraces its path such that to move downwards. Downwards in the sense negative axis. So therefore, velocity becomes negative. Velocity becomes negative, right? So graph is like that. Y equal to minus mx. Y equal to minus mx in the form of y equal to minus mx. But here, if graph starts from origin, we have to write like that. But here, before this segment, we have this segment during time of ascent. See, what is the time from here to there? Time of ascent. Here onwards, time of descent. So we have to include this part also. So we are not supposed to start graph from this. We have to start from here see, like that. Like that. So what here it is time. Here it is velocity. Now what is this dotted line? This portion. This portion is represented somewhere here, right? Dotted line. Okay. So this is the graph during time of ascent. This is the graph during time of descent. So on combining both, you'll have a picture like that. See, time, here velocity. Now graph is like that. Graph is like that. See, what is time here? 0. Here it is TA. Here it is TD. So 0 to TA, TA to TD. So during time of ascent, velocity is negative and decreasing and becomes 0 at the time of ascent, right? During upward motion. During downward motion, velocity starts from 0 and in a negative direction, velocity increases. Why? Because V is proportional to minus T here. V is proportional to minus T, or minus V is proportional to T, right? Therefore, as time increases, velocity increases during downward motion in a negative direction. So that's why graph is below the axis. Here it is above the axis. See, in first case, during upward motion, velocity is upwards. Otherwise, direction of motion is upwards. So velocity becomes positive. So velocity becomes positive here during upward motion. During downward motion, here body moves downwards, means direction motion is downwards, means velocity negative. So graph lying below the axis. So this is the combined graph. Okay, during upward motion and during downward motion. This is upward motion, this is for downward motion. So this is the required answer for velocity time graph, the body projected vertically upwards, right? This is the required graph. Coming to one more numerical, that is 2014 and 2020 mains. 2014 and 2020 mains. So this question appeared twice in previous exams, mains exams, 14 and 2020. What is the question here? Means one ball, that is a tennis ball, dropped from a height h above the ground. See, this is what one ball dropped from a height h above the ground. So after striking the floor or wooden floor here, this is what wooden floor. From the question, it is wooden floor. See here, billiard ball is dropped from a height h above the wooden floor. So when it is dropped, it strikes the wooden floor and rebounces to some lower height, like that. It rebounces to a height h by 2, right? After impact with the wooden floor, see this ball raises to a height of h by 2. Why it raises through smaller height than the height from which it dropped? Means here during impact there is some energy loss during the impact with the floor. So because of that reason, here ball raises through smaller height than the height from which they actually drop, right? Okay, now the question is to write a graph of velocity versus height. Velocity versus height. Velocity versus height graph. Velocity versus height graph, right? Now during downward motion, first of all, during downward motion, see, downward motion is here free fall, so u equal 0. So u equal 0. Here tennis ball was dropped freely from a height h above the wooden floor, right? So freely falling body means here u equal 0. A becomes minus g. Why? Because gravity always downwards towards negative axis here on the board plane, right? So u0 A equal minus g. Okay, right? Now what is the instant velocity here? the velocity with which it strikes the wooden floor, let it be v. What is the height from which it dropped means h. Right? Now take v square minus u square equal to as. V square minus v square equal to as. V means final velocity with which it strikes the wooden floor. U means initial velocity at which it dropped, and a means acceleration. Now see here, v square minus u square means 0 and equal to it. A means what? A means minus g. S means minus s, for example. Minus s. I am not writing h. I am writing symbol s only, but displacement downwards from the level of projection. So s becomes negative. I am not writing h. I am writing symbol s only. Later on, I will change. Now v square equal to minus plus. V square equal to 2g. Yes. V equal to plus or minus root 2gs. In fact, direction motion is downwards. See here, in this part of the segment, the direction motion is downwards. Therefore, we have to commit with negative sign here, not with positive sign. Why? Because direction motion is downwards. Therefore, V becomes minus of root 2gs. This is the required form. V equal to minus root 2gs, where s means what? S means distance covered by the ball here. This is what ball. Okay. Tennis ball. This is what? Tennis ball. Where s means what? It's not height. That is, in fact, that is the distance covered by tennis ball. Now I am writing here. Continuing here. See, V equal to minus of root 2gs. S means what? Distance covered. S means what? Distance covered by the ball, tennis ball. Okay, right? Now here see, if S equal 0, if S equal 0 means when it just dropped. When it was just dropped, what is the velocity? 0. So if s equal 0 means distance covered is 0. Means when it was just dropped, distance covered is 0. Implies velocity equal to 0. Implies v becomes 0. Implies height of the 0. Height equal to h. See here, it is dropped from a height h. Right? Here height is different from distance covered. Both are not same. S means what? Distance covered, but height is different from distance covered. See, in this formula, S representing distance covered only, not height. Suppose if S equal to 0 means presently we are at level of dropping on here on. So when S0 means distance covered is 0. When distance covered is 0 means what is the height from the ground? H. So height equal to h. Now what is the velocity at this height? Means just dropped means 0. So implies V becomes, velocity becomes 0. Velocity becomes 0. Suppose if S equal to h, suppose body covers entire distance. S becomes distance covered S equal to h means your body reaches ground, strikes the floor. Now what is the height here? 0. See once again. If S equal distance covered S equal to h, your body dropped from somewhere here. Distance covered becomes equal to h means it strikes the floor itself. So therefore, if distance covered equal to h implies height equal to 0. Height equal to 0. Why? Because it just reaches the ground. At that height, 0 height. At this 0 height, what is the velocity? Minus root 2g. Implies velocity equal to minus root 2g. S means h. S means h only. Right? So when it strikes the floor, height equal to 0, but velocity with which it strikes the floor means minus root 2g h. Now same parameters we can represent in graph like that. We can represent like that. See, this is what I am This is what this is what h height. Here it is velocity, right? When height is h, what is the velocity 0? When height is h, suppose here it is height here, height. When height is h, suppose this is what h. When height is h, what is the velocity? 0. Means this is the point, corresponding point, right? When height equal h, velocity becomes 0 from this data. Now coming to next point, when height is 0, what is the velocity? Minus root 2gh. Minus means somewhere here, minus root 2gh. Velocity becomes minus root 2gh, right? Now what is the variation of velocity with height? Means like that parabola. Why? Because see, this expression is in the quadratic form, quadratic expression. In case of quadratic expression for velocity and height, then we can have parabolic relation. See, variation of velocity with height means parabola, like parabola, right? When height equal 0, velocity becomes minus root 2gh. When height equal to h, velocity is 0. When height equal to h, velocity equal 0. So this is what variation like. So initially velocity is 0. Later on increases, and when it strikes the floor, maximum minus root 2gh. Why it is negative side means during downward motion velocity is negative. That's why graph is below the axis. When it strikes the floor, height becomes 0. When it strikes the floor means height from the floor 0. So therefore velocity minus root 2gh. Okay. So that's what I want to tell you. Now coming to upward motion. This is what downward motion. Coming to upward motion like this. Okay. Now coming to upward motion, see here. Coming to upward motion like that. Rebounding from the floor. Ball is rebounding from the floor with some velocity u and reaches height h by 2. At highest point velocity becomes 0. See here, as body or as ball raises through smaller height than the actual height through which it dropped, right? Here the rebounding velocity or the rebounding speed is somewhat less than the speed with which it strikes the floor. Why? Because there is some loss of energy during impact, right? So that's why the u is not equal to velocity of striking here. This is what velocity with which it strikes the floor. Here the velocity with which it raises or rebounds. U is not equal to v. Here rebounding speed is not equal to velocity with which it strikes the floor. In fact, u is less than v. Now how to find? Take v square minus u square equal to s. V square minus u square equal to s. Here v means 0 for this segment, v 0 final speed. Here initial speed unknown. That is 2 into a means minus g. Always minus g. S means what? H by 2. That is minus cancel, 2 cancel. U square equal to gh. U equal to plus or minus root gh. But see the direction motion upwards. As direction motion is upwards, we have to commit with positive sign. So u becomes plus root gh, which is less than velocity with which strikes the floor. Less than v. U less than v. Why? Because there is some loss of energy. There is some loss in energy during impact with the floor. Right? Now see, during rebounding, when it just rebounding, it has maximum speed here. Right? When h equal 0, when h equal to 0 implies what is the velocity u equal velocity of rebouncing equal to plus root gh. When height h means height, when height equal to 0, when height h means height, when height is 0 means just rebouncing from the floor. At that instant, what is the velocity u? That equal root gh. When it reaches highest point during rebouncing, when height equal h by 2. When height equal h by 2. Now what is the velocity here? 0. Velocity equal to 0. Now these 2 points we have to represent the graph. When height equal to 0, somewhere here. When height equal to 0, what is the velocity? U equal to root gh. It's not minus root 2gh. Less than root 2gh. See here, u equal to root gh only. Root gh, not root 2gh. So this is what root 2gh. Root gh means a smaller bit. Like starts from here. This is what root gh only. Root gh. Right? So when height equal to 0, what is the rebouncing speed? Root gh. Not less than root 2gh. This is what root 2h. Here it is root gh. Smaller bit. Smaller interval, here larger interval. So when height equal to 0, rebouncing speed is root gh. Right? When height equal to h by 2, see this one h, here it is h by 2. H by 2 like that. When height is h by 2, what is the velocity here? 0. So join these two like that. Join these two. Parabolically join these two. Why? Because here also equation v square minus u square root 2a is nothing but quadratic expression. So the variation of v with s or h definitely parabola. So when height equal to 0, velocity equal to root gh. When height equal to h by 2, velocity is 0. So this is the correct presentation for that situation. Am I right? So velocity versus height graph like that. Okay. Now let us see time of ascent, time of descent and maximum height in case of presence of air resistance. Okay. Presence of air resistance. Time of ascent, time of descent, maximum height. In case of body projected vertical upwards, in the presence of air resistance, right? Effect of air resistance. On time of ascent, time of descent and maximum height. Effect of air resistance on TA, TD and maximum height. Right? Suppose here if air resistance is neglected, if air resistance is neglected, time of ascent is equal to time of descent. TA equal to TD. Irrespective of mass of projected objects. Means here see, the body is projected vertical upwards with some initial velocity. Now it goes up and again retraces like that. Okay. With a speed which is equal to speed with which it is projected up. See here, this is what point of projection. It is projected vertical upwards with some initial speed u. It reaches or arrives the same point with the same speed. In case of if there is no air friction. Here, time of ascent becomes equal to time of descent. Ta equal to T. Right? Ta equal to T. Okay. Now here, if two bodies are dropped, heavy body and a lighter body like that from the same height h. See here, it is heavier body means large mass, here it is lighter body, very small mass. Both are dropped from the same height above the ground. Both are dropped from the same height above the ground. Right? Now in this situation, what is the time taken by both to reach the ground? Let us find. See here, for first object, S equal to ut plus half at square. S means minus h, u means 0, dropped means u0, here also u0, plus half into a means minus j into td or t. That is h equal to half jd square, t equal to root over 2h by g. See, time taken by this heavier body to reach the ground equal to root 2h by g. Of course, for this lighter object also you will get same answer. Why? Because s equal to ut plus half h square. S means minus h, u0, here half into a becomes minus g, here also t square. That is t equal to root 2h by g. Valid for both objects, irrespective of their masses. Right? Why? Because here the expression doesn't involve any mass. The expression doesn't involve the term mass. So therefore it is independent of mass. Right? So whatever the mass here, whether it is light or heavy, right? So all takes same time to reach ground when dropped from the same height. So this is valid in case of there is no air resistance, right? So in that case, time of ascent becomes equal to time of descent, and the speed with which it arrives the point of projection, which is equal to the speed with which it is projected up. So this is also valid, right? But in a real picture, it's not like that. You can find some air resistance in reality, right? So therefore, time of ascent, time of descent, which mismatches time of ascent. Of course, the speed with which strikes the point, reaches the point from which it is projected, somewhat different. Means v is not equal to u. Means the speed with which arrives the point of projection mismatches the speed with which it was actually projected, right? That's what I want to tell. So, like that. Now see, now here, effect of air resistance on time of ascent, time of descent, and maximum height. Let us discuss now. Let us discuss time of ascent. Time of ascent. First one, number 1, time of ascent. TA, time of ascent. See here, body is projected vertical upwards like from the ground, right? Here that is subjected to air resistance apart from gravity. Okay, so we know that gravity always acting vertically downwards. But air resistance always acts opposite to the direction of motion of the object. See here, body moves upwards, so air resistance downwards. The body moves downwards, air resistance upwards. But here, G always vertically downwards. So here, as body is projected vertical upwards, see the direction of motion upwards. So it is subjected to air resistance downwards. So A means retardation due to air resistance. So G plus A, that is the combined retardation experienced by the projected object here. Am I right? So G means acceleration due to gravity, A means retardation because of air resistance. Why it is downwards means this is opposite direction of motion. See, direction of motion is upwards, A is downwards. Right? So what is the net retardation? G plus A, net retardation. Because of G also here body is under retardation. Why? Because G is against direction of motion. A also against direction of motion. So both together, G plus A, both together acts as retardation. So therefore, V v equal to, see here, velocity projection is u, at highest point v equal to 0. Now take v equal to u plus at. V means 0. It is u means u only, positive. Why? Because body is moving along positive axis on the board plane. Plus a means what? Is it g plus a or minus of g plus a? See, minus of g plus a, both acting downwards. That is minus of g plus a into t means time of ascent, t, right? That is plus or minus, minus g plus a into ta becomes equal to u. So ta equal to u by g plus a. So when there is air friction, what is the expression for the time of ascent? U by g plus a, right? U by g plus a, which is less than u by g. What is the usual formula? When there is an air friction means u by g only, but here it is u by g plus a. Means the denominator increases means value decreases. So less than u by g, right? Now coming to time of next one, coming to maximum height. Maximum height, h max. See once again same picture. Velocity projection u, h max at highest point velocity 0. So both g and a acting downwards. A means retardation because of air friction, g means retardation because of gravity. Both acting downwards together. So take v square minus v square equal to 2as. V square minus v square equal to 2as. V means 0. U means u only. 2 into a means again minus of g plus a. Both g plus a downwards means minus of g plus a into s means what here? H max plus H max. That is minus minus cancel. H max equal to u square by minus minus cancel 2 into g plus a. What is the usual formula? And there is no air friction means u square by 2g. But here it is u square by 2 into g plus a. Is it greater than u square by 2g or less than u square by 2g? Less than u square by 2g. Means maximum height also reduces because of air friction or air resistance. Time of ascent also reduces. Right? Now coming to third point, that is time of descent. Time of descent. See here, after reaching highest point, see when it is projected up, it goes to highest point, again retraces like that. So moves down, accelerates downwards. See here, what is the velocity at highest point during downward motion means 0, right? S means minus H max. Why? Because motion is downwards, that is towards negative axis on the board plane. So S becomes minus H. Now coming to G and A, G downwards, A upwards. Why? Because retardation due to air friction, A always opposite to the direction of motion. See, body is retracing its path downwards. So direction of motion is downwards. So retardation due to air friction is opposite, that is upwards. But irrespective of direction of motion, G always downwards. Right? Now take S equal to ut plus half its square. S equal to ut plus half its square. S means what? Minus H max. U means 0 into T plus half into what is A? A means net acceleration. Here also A means net acceleration. So what is A? Means G downwards minus G, A upwards plus A. So A along positive axis plus G along negative axis on the board plane. So G negative, A positive. That is minus G plus A. Minus G plus A into TD. Time of descent means TD square. That is minus h max equal to, this is what t, 0 into td, right? 0 plus of, take negative sign common here, minus half into g minus a into td. See here, take negative sign common, minus half g, minus half into g minus. So minus minus cancel. We will left with h max equal half into g minus a into td square. What is h max here? U square by 2 into g plus. Now replace here. H max u square by 2. U square by 2 into g plus a. 2 into g plus a, that is equal to half into g minus a into td square. Now 2 to cancel, we left with the td square. td square equal to u square by g plus a into g minus a. td square equal to u square by g plus a into g minus a. Make it subject td, that is u by g plus a into g minus root g plus a into g minus, right? That is g square minus a square. That is u by root over g square minus a square. Root over g square minus a square. This is what required equation for time of descent, which is greater than time of ascent. See here, T equal to u by g plus a, but Td equal to u by g plus a, root over g plus a into g minus. How to estimate whether Td is greater than or less than Ta means take one numerical values. See here, suppose Ta equal to u by g plus a. Suppose I am taking a 1, g 10, that is u by 10 plus 1, that is u by 11. Coming to Td, u by root over g plus a, 10 plus 1 into 10 minus 1, that is u by 10 plus 1, 11, here 9, 11 into 9, root 19. Root 99. Suppose here it is root 110. Root 99 means less than 10. Less than 10. So therefore Td, from this we can say that Td is greater than Ta. Td is greater than Ta. What we usually expect means, what we expect, time of descent may be less than time of ascent. But in fact here it is evident that Td is more than Ta. Time of descent is more than time of ascent. Am I right? Time of descent is greater than time of ascent. That is, Td is greater than Ta. Means Td is not equal to Ta. Td is not equal to Ta. Time of descent is not equal to time of ascent in the presence of air resistance. Right? Td is greater than Ta. Time taken to reach ground from highest point is greater than time taken to reach highest point from the ground. Right? Now coming to one more point, comparison of speeds. Suppose it is projected with speed u from the point of projection. Now it reaches the same point with some other speed v. Means v is not equal to u. Now what is the relation between v and u? Let us discuss. V and u. V and u. Right? V and u. See here, the body is projected like that with the speed u, reaches highest point and retraces the path. I am riding by the side, but with the speed v not equal to u. See, velocity of projection is u, but velocity with which it reaches the point of projection is v, which is not equal to u. Means there is some difference between these two. Now what is the relation? Now take s equal to ut plus half h square. See here, for this motion it is u for this segment, remaining segment here, u equal to 0. take this segment v square minus u square equal to as. V square minus u square equal to as. Take this second segment, we are in downward motion. V square minus u square to as. V means unknown, u means 0, here 0. 2 into a means during downward motion. What is a here? Net acceleration, g downwards, a upwards. So net acceleration means minus g plus a into s means during downward motion. What is s? Minus h max that is v square equal to, see here, v square equal to, now here it is negative sign, multiply with negative sign, that is 2 into g minus a into h max. What is h max here? U square by 2 into g plus a, that is v square equal to 2 into g minus a into h max means u square by 2 into g plus a. U square by 2 into g plus a, right? 2 cancel, that is v becomes equal to v square equal to g minus a by g plus a into u square. Make it subject b, square root of u square by, say, plus or minus u into root over g minus a by g plus a. V equal to plus or minus u into root over g minus a by g plus a. But here v, we have to commit with negative sign. Why? Because v means downward motion. See, the segment partly is moving downwards, so v becomes negative. So I am taking like that. I am taking with negative sign, v becomes minus u into root over g minus a by g plus a. Right? So when it is projected vertical upwards with u, it reaches the same point with v, which is not equal to u. In fact, v less than u. See, v less than u. Neglect this negative sign for the time being. That is v equal to u into root over g minus a by g plus a. See here, numerator is less than denominator. So therefore, v less than u. So v less than u. That's what I want to tell you. Okay. So okay friends, here what are the inferences? In presence of air resistance means if there is air friction or air resistance, time of ascent is not equal to time of descent. In fact, time of descent is only greater than time of ascent. Moreover, the speed with which it strikes the point of projection is less than the speed with which it is projected vertically upwards. So why? Because this is the expression for the speed of arrival the point of projection, that is v equal to minus u root over g minus a by g plus a. Okay friends, with this we have successfully completed motion in 1D. So apart from my lectures and illustrations, I have to go through DPPs and more illustrations, do hard work. So in next class onwards we are going to start motion in 2 dimension, that is motion in a plane. Okay friends, thanks.